Okay, send a text or an email if you're there. Curious. 'Cause yes, I know as much as you do. Dun, dun, dun. Are you texting her?
Yes.
Are you there? We could all text her, like, what do they call that when you...
Spam?
No, when you,
Bombard.
yeah, like when they, flash mob, text
Oh.
mob. Okay, so she has these, and we'll go over them either way, whether she's there or not. So that she can,
This took me a fat minute.
you didn't take long to do this?
Oh no, it took me a fat minute. It didn't take me long to do.
This is what she has, look at that.
Whoa.
It's the whole darn assignment.
Really?
Really?
That's what happens when you try to teach yourself.
Are you there? Send a text, send an email. I bet she's not there.
I
Comment on the live stream.
Yeah.
Natalie responded to me when I asked her about forensic stuff, so at least they know there's somewhere where they have cell service.
Natalie Jobbins?
Yeah.
Okay, well, we'll do this, we'll go over
Were the
these.
games streamed last night? Or the
Yes.
other week?
But you had to pay for them.
Yeah.
They played last night?
Yeah.
Okay, so this was advanced factoring techniques.
6A for sure.
Yeah, you have 6A?
6A, 11. 11 should be kind of like just a comprehensive thing.
Here, I think she just wanted the answer.
And then 14A.
Yeah. What about you, Zilla?
I'm good.
Come on, no way, I don't go, yeah. You want to just do them all?
Yeah. Oh, no. I thought you said, did I just do them all?
So,
Like, yeah, I
okay,
did them
so
all.
7A, well, let's just do them. You guys want to help me?
Yeah.
Good. So we got a factor for number 4, x squared minus
3x.
3x
Minus 4.
plus 2.
Oh.
And x squared minus 3x minus 24. So what are we supposed to recognize with that?
There's x squared minus 3x in there.
Think of that as u, right?
So
That's, I mean, I like to teach it that way. I like to teach it as a substitution because I think it makes it so you don't forget
Stuff.
and miss. Yeah, you don't miss little details of your values. So if you factor u squared plus 2u
Chunking.
minus 24, we need to, it factors over the integers. Into u,
U minus 4 and then U plus 6.
yeah, you need more positives, you need 2 more than negatives. So then from there, you come back and you plug that in. You have x squared minus 3x for u minus 4. That's one factor. Here's your other factor, x squared minus 3x plus 6. And then you ask, can I factor those? So we have to have a positive and a negative, right?
Mm-hmm.
And what do they become?
X minus 4 and x plus 1.
1 times 4.
Did you have
Four.
to chicken for the other one?
I just put in the quadratic for 2.
Yeah,
so-
me too. But
Yeah.
that's
This,
not
what,
enough.
Oh, yes,
you can't do that one?
You can't do that one.
Why?
Or at least I found I couldn't.
I couldn't factor it either.
Because you either have 2 negatives
Mm-hmm.
which add together, and that would be the largest ones would be 2 and 3, and that would be negative 5x. And that's as far as you can go. And then you have 6 and 1, so it'd be negative 7.
So this is 9 minus 4 times 6 is 24, which is a negative 15.
Mm-hmm. So
That's
they're both imaginary.
Yeah, so there's two imaginaries.
Mm-hmm.
So if you take that, if you do your discriminant off to the side like this when you're working the quadratic, sometimes it can be more efficient. And we've got a negative b, so that would be
3 positive.
3 plus and minus the square root of negative 15 all over 2. So that goes to 3 plus and minus I root 15 over 2.
Yeah.
So those are your other two factors, and they would get plugged into there, and then you're done. So there's your answer. Take each of those, put them in there, and you got it. Okay, So what about 5? Graph the set of ordered pairs. I gotta use this.
I was so happy I got this one. I couldn't really believe it.
So this one's y cubed and xy squared minus x squared y minus x cubed is equal to 0. Boy, that's a pattern. Is that a pattern? Could you work backwards from the theorem on that one?
Why wouldn't you just do grouping?
That's
Or, okay.
I'm just wondering if you can work backwards from the theorem.
No,
Isn't
sir.
this one of the odd differences?
Yeah, except it's kind of messed up a little bit. And like, it should be minus, oh yeah, there's minus x squared y,
Oh no, this is not one of
then
them.
it should be plus
Yeah.
x.
If that was
yeah,
plus,
it's
then you could use the theorem and work backwards.
Yeah, it's not quite.
It's not quite there, so then we gotta figure that
Stuff
out.
we can do,
What can we do?
what we can do is you can take y squared out of the first one, and have y squared times y plus x, and then you can take x squared out of the other one, and then that would be y minus x, and then, you can do
Plus.
another, you can just, yeah. you
Oh,
can
is this
do an-
plus x? Because that's so that's a negative.
Right,
We
right.
do it that way.
Yeah.
Is that right? Yeah,
Yeah.
so that becomes, yeah, so there's your negative, there's your negative.
And so then you can do y squared minus x, x
Yeah.
squared multiplied by y plus that.
Okay, so
And then
that,
bada
there's
bing,
one,
bada boom.
And difference of squares.
yeah, this is a difference of squares. But we gotta graph that, don't we?
Yeah, it's just like two crossing them.
So if you're gonna add them together, they both have to be 0, right?
They end up being, I found that they end up being like two crossing lines, I think with a slope of 1.
Yeah, so this is equal, so they're equal to 0, so that's like, that's the origin.
Yeah.
And then this one here, y is equal to,
The opposite
that's
of
y
x.
is equal to x.
The opposite of x.
Yeah, but
Oh, yeah,
that's
yeah,
y is equal to x. So there's a set of solutions. And then y plus x is 0. That's like this, isn't it?
Mm-hmm.
So how, is that how you graph it?
Yeah.
So you have two intersecting lines at the origin. And the fact that these two intersect at the origin accommodates for that. Wow. That's weird.
I know it is.
But there it is, yeah.
I looked in the back and checked my answer.
So we just look at little pieces of it. That's gotta be a 0, that's gotta be a 0. The only way that can be 0 is when y is equal to x. Because if we do this, we rewrite it as that. In this one, if we did this, we would then have y is equal to negative x, and that's your negative 1 slope. That's your positive 1 slope. Factor the polynomial x to the 6th minus 1 using chunking. So x to the 6th minus 1, this is number 6. So we want to chunk, and they say we're going to chunk it so that u is equal to x squared.
I just wasn't sure how to, I don't know why my brain was kind of having a seizure
Well,
trying to keep things.
What, I guess, if u is equal to x squared, and you think about this, that's this amount. So if we say that that's u, we have u times u, which is u cubed minus 1. So let's factor that. And then come back and put x squared back in for u as it is factored. So we could rewrite this as u cubed minus 1 cubed, right? And then we could use the theorem. So the theorem would be,
X to the second, or using u, it's u minus 1 quantity u plus 1u plus 1.
U plus U plus 1?
Yes, it's all.
Because it's 1u, but 1u equals u.
So that's
Oh,
how
U-
it is,
U
1
squared.
U plus U plus 1?
No, u squared.
Yeah, okay, I
U
was gonna
squared.
say, we gotta have powers in here when we progress and go down.
Yeah, I've got the
So
in.
these are all pluses when we have the third power.
Mhm.
Okay, difference of cubes. All right, so now we come back and put x squared in, yes?
Mhm.
And you have x squared minus 1.
Mhm.
And then you have x squared
To the fourth.
squared, which is x to the 4th, plus x squared plus 1.
Mhm.
So can we factor this?
No.
Well,
Oh wait, yes,
sure we
yes,
can.
that's the difference of squares. So.
That's a difference of squares.
Mhm.
So that's x plus 1, x minus 1. Okay, now how about that? Can that get factored? I bet you it can.
Yeah.
Try by splitting this up
Mhm. X squared, x
and
squared.
x squared, and everything's positive, and it's gotta be 1, and then just check and see if it works. Let's
No,
see. Oh,
that'll
it
be
doesn't
2x
work.
squared.
It doesn't work. Shoot. So, here it is. What if we factored this? I think this should be factored first. That becomes what? We can't do it, can we?
No, we can't.
U squared plus U plus 1. Is this correct out of the theorem?
It is correct.
Okay, so then what do we start
Because
with?
it's ax, or it's a squared plus ab plus b squared. And b right now is 1. So we could put a 1 in front of
No.
the u.
Wait a second. What does the theorem say?
A squared minus b squared equals quantity a.
Squared?
Mhm.
We have cubed.
Cube, yes, cube.
See, before I go and do the quadratic on this, I want to make darn
No,
sure.
it's cubed.
Because otherwise we just go down a bad rabbit hole.
Cube equals a minus b, quantity a squared
Plus AB.
plus ab minus b squared. No, plus b squared.
Yeah.
Plus.
Plus, yep.
So we're okay with this.
Mhm.
You're certain.
I have it right here. Except it's with X and Y if you want to be
Okay.
cool about it.
So u squared, u cubed is just u and 1.
Mhm.
U minus 1, u squared plus u times 1 plus 1 squared. Okay. So then we gotta go through it, don't we? We can't go here. We're gonna end up with 2 by applying the quadratic, right?
Mhm.
All right, so again, in the spirit of b squared minus 4ac, that's 1. B squared minus 4 times a times c is negative 3. So this becomes
Wait, what are you doing?
I root 3.
Mhm.
How did you compose that? Sorry.
Over
This is
2.
b squared minus 4ac. This is the discriminant. B squared minus 4ac is the discriminant.
Mhm.
So we have I cubed and then I root 3
Mhm.
is the result of the discriminant taken out of the radicand. So now we have b squared, which is 1,
Mhm.
and we have,
Over 2.
wait a minute, no, we have negative b,
Yeah, negative 1.
negative 1, plus or minus I root 3 all over
2.
2. So this is a negative half I
Plus.
plus I root 3, and this is a negative over 2. Negative half negative
yeah.
half minus I root 3 over 2. So 1, 2, 3, 4.
And 2 of them have a multiplicity of 2.
They must, huh? Because we haven't gone any further. What's got the multiplicity, you think?
Probably the imaginary ones.
But I'm guessing the real ones.
Well, did we put x squared back in?
Mm-hmm.
No,
Mm-hmm.
no.
What?
No,
Okay.
no, we haven't.
We're using U though.
Because we're doing this for u. We're solving for u.
We didn't solve.
Oh,
What?
u is equal to this.
Mr. Dagan, that second line below the U, everything, we did put x squared in. We did substitute x squared in.
Only here,
Uh-huh.
not here.
Oh, I see what he's saying. Okay, that's equal to U.
This is u,
Okay.
And,
so we're not done. U is equal to these two.
okay.
But, okay.
So then this is in terms of u right here.
Oh, we have to take
Oh,
x squared
shoot.
out. No.
And u is equal to x squared.
Mm-hmm.
So this is equal to x squared.
Uh-huh.
Ooh. Ooh. So, oh, this is goofy. So if this is equal to negative 1/2, here, let's just take one of them, okay?
Over 2.
That's one of them.
Yeah.
So now, that gives us plus and minus that. And then we do it again with negative 1 minus I root 3, and that gives us another one. Another plus and minus. So yeah, so this gives us two roots. The positive and the negative root, square root of that. The square root of I is the fourth root of negative 1. Golly. That just seems complicated. Like there ought to be an easier way to straighten it out.
So why aren't they factored when we use the theorem of cubes?
Here?
Yeah.
Well, because this is this is capable of being factored further.
Okay.
This is what it would be by the theorem and be.
I'm sure that question.
And that just gets to go further. So it seems kind of weird that we would take the root of a root. And I would like to look back at the theorem if do you mind humoring me?
Mm-hmm.
Where's the theorem? Do you know?
482.
Thank you. 482.
Oh wait, what if we?
So x cubed minus y cubed is x minus y, x squared plus xy plus y squared. Yeah. Yeah.
Wait. But right below it says any binomial that is expressed in that form can be factored using the formulas from
Right.
here.
So x squared plus xy plus y squared can be factored using one of the formulas from the theorem.
So then they're factored using. So
Yes.
they are factored.
Can be factored using one of the formulas. You know,
And they're factored.
is it possible they want us just to stop here and say x to the fourth plus x squared plus 1?
Would you want
What
us?
number is this?
6.
Yeah, so we don't know, and I don't have the dang book here. Do I? The Gringo guide. This is geometry. Of course, I don't have the FST book here. So, let me make a note to myself. 7-8, number 8. And let's stop, okay?
Okay. Number 6.
6, that's right, thank you. So let's stop there,
Okay.
just because I'm not certain.
That's pretty
I
goofy.
mean, I can take it to that, but it's not very neat and clean. And,
Seems just like a little bit too much.
yeah, and I'm wondering if, by convention, we would stop at substituting back in and saying, by theorem, this is,
Yeah, I think that's
Okay.
where it wants us to stop, is just to have X.
Oh wait, we
to the
can check on
fourth.
7. Because on 7 I had,
Did you do 7?
yeah, on 7 my answer was in the factored form using the, see where it looks like it is.
Yeah, but that one came out.
So yeah, so 7 they have it where that it's factored, no.
Do they go beyond?
No,
I don't
no,
think
that
they
one doesn't
do.
use the cubed, but,
There's one I know you're talking about where it just kind of stays.
oh, is it 15? 15 I
Yes,
think.
that's exactly what it is.
15 is t cubed plus u cubed.
So you just put it into the theorem.
And it
don't-
does stay that way.
So that's
factored.
reviewing, so that's just dealing with it in 7 form. So it just comes back out in the t minus u quantities taken times.
Still goes
And then the
So
back
they,
of the
they
book.
don't factor that, do they?
No.
Okay, so
So
maybe
they-
we are not, maybe we're trying too hard.
Yeah, they just wanted to go that far.
Try hard mode.
Still nothing from Haley saying I'm alive. She must be on an airplane.
Hold on.
Or she is skipping out on class.
Uh,
Playing hooky.
No, she said I'm gonna be on. So, yeah,
Okay.
okay. In this
She says the
ever-changing
gym Wi-Fi
world.
sucks.
Oh.
What did you say?
She says the gym Wi-Fi sucks, and I had my phone on silent, so she was trying to get my attention by taking
Oh.
hay a whole bunch of times.
Okay,
I'll just.
so they're in the gym. Okay, all right, moving forward. 8, yes?
Mhm.
So you have, can you just read it to me? Z squared?
Z squared plus ZX minus YZ minus XY.
Okay.
Good job, Zell.
I bet you there's something in there with like
Grouping.
grouping, yeah, chunking. I bet you there's something here
Yeah, you take up Z.
Z.
and do something here. You could pull out a Z,
Mm-hmm.
and then you have a, oops, you have a Z
Plus X.
plus X.
Mm-hmm.
And then you do the same thing for the other side, but, with Y.
And then you have a negative Y and a Z plus an X.
Mm-hmm.
This is why we teach you in 7th grade to keep your negatives straight. So then this just becomes a Z minus Y, right?
Mm-hmm.
Oh
Times
my
Z
gosh.
plus X.
Oh my gosh, look at
Yeah,
there's
I
a
mean,
similar
that's-
term.
That's it, right?
Yeah.
That's as far as we need to go.
Mm-hmm.
Number 8,
Oh.
That is number 8.
Well
Right.
done.
number
Oh,
11.
This one was a silly goose. I was not
This was a-
understanding this.
Are there other words for it?
Whoa, wait, we're supposed to do 11?
The
Hold
germ
up.
function of X
Where
What
are
was
we?
the homework?
is X
1 through
squared,
8, 11, 13 through
5X
17,
and
18.
10. And we wanna,
Yeah. I'm so confused.
so we're
Okay.
gonna simplify that function of X minus the function of B
Over X minus B.
over X minus B. So if the function of X is this, the function of B is gonna be B squared plus 5B.
So it's just a different variable?
Well, yeah,
Okay.
I think so.
But it's that simple.
Yeah, that makes sense
I
because
think
you're using
so.
a similar function.
Yeah, so it just says, let's see, so let that exist. So then simplify that. Okay, so then it's just X squared plus 5X plus 10. And then here's how I'm gonna do it. I'm gonna put B in there, minus B squared minus 5B. I think, maybe not, let's not do that just right away. Let's write it as
Function.
B squared plus 5B plus 10. Let's see if it appears. So we gotta do the function, and then we gotta subtract. And then X minus B. So, if you're gonna simplify this,
You can get rid of 10 right away.
you can get rid of 10.
Or you could, it doesn't want us to
But be
subtract.
careful to get rid of things right away, because they might be useful to do this work. We gotta take the function, subtract the function, and then divide it by X minus B. And think about how we simplify fractions. How do we go about simplifying fractions?
You remove like terms or terms that can be divisible.
terms that
Or like,
can
can you
cancel out, yeah, we can
out?
divide them out, you take numerator divided by denominator. So, you have a denominator of x minus b, which is a relatively simple term. Just, there's two terms in subtraction, so what do you,
So if you write it all out, you can see that there's a whole bunch of x values there. Oh no, but they're not multiplied, never mind, never mind, I got nothing. Does it want us to factor them out? I don't see how that would.
Why wouldn't we subtract the tens and then complete the squares? And then we've got
I forgot how to do that.
then we've got x squared plus 5x plus 25 minus b squared plus 5b plus 25.
so you wanna complete the square on each of those?
Yeah, why not?
Wait, I forgot how to do that.
And then we add 100, or we add 50 to the. And would we add 50 to the 0, or to the other
Then
side?
you're making it, you're building it up again.
Okay.
You just got rid of a c value.
But then that way we'd be able to factor them down. Maybe.
Yeah,
You
then they're a square. So let's just mentally do completing the square on the x's.
Would you,
So you'd have 2.5 squared, so it'd be x squared plus 5x plus 6.25. And then over here, you'd have b squared plus 5b plus 6.25.
Mhm.
And now you're back to subtracting the 6.25 and getting back to 0, so that's.
Well, if we have 6 to complete the square.
Yeah, so, okay, so let's say you have that, so you got x squared and 5x and 6.25, that's completing the square, right?
Well, if we just had.
But that's,
Okay.
but
Okay.
But let me say something.
Okay.
You are assuming then,
That's equal to 0.
that
Oh.
it's equal to -10 because you got rid of the 10, and then you added 6.25, so we're saying that's equal to -3.75. Now we're saying it's equal to something.
Mm,
Does this say it's equal to anything?
no.
No, that's simply something that needs to be simplified. So we're not completing the square. But we do get rid of the 10s, and now what do we have?
silly goose.
You were on the right track.
So you're grouping them out?
Can you?
So you can take x out from the first one. Okay, hold on, let me
Oh,
write
yeah.
this down.
Mhm.
And what do you take from the second one?
B. You got b plus 5.
All right, now what do you got going?
So now that equals x plus 5. Oh, x plus 5 quantity b plus. Oh no, because you don't have common. So wouldn't it just be x plus 5 times b plus 5? Or do they
Yeah.
have to be the same?
Crap. Yeah, they
'cause
have
you
to be
can't-
the same.
Can't just distribute.
Oh, I can take this x minus
Right,
x.
I was thinking x minus b would be really nice.
Yeah.
It's not right now, is it?
No.
It ends up as being really nice.
Yeah, well, you went looking. Don't go looking.
I did it after a lot of struggling because I just wanted to see how far you could even go with it, and I didn't even really look at the answer. I just kind of like processed its structure, and it was seemed pretty.
Here's what I might
Definitely.
suggest we do. This seems to be a dead end.
Okay.
So let's take this and let's write it out, term by term. X squared
Plus 5.
plus 5x
Minus.
plus a negative,
Mm-hmm.
oops, b squared.
Plus negative 5b.
I'd like to have something better, plus b squared plus a negative 5b. Now we can move them.
Okay.
We can move them around. And let's just put these two together.
Oh wait, I have a question. So
Yeah.
we took. Oh no, we just subtracted. Okay, yep.
So let's do this. Let's move it, and then let's write it negative.
Mm-hmm.
And then let's have 5x and subtract 5b. All over x minus b.
That's totally it. And then no.
So
Take.
now let's just work with this
Mhm.
and work with that. So x squared minus b squared, can we do anything
That's a
with
difference
that?
of squares.
But then it would be multiplied, right?
It would be a difference of squares plus 5 quantity x minus b.
So it'd be plus
Mm-hmm.
5x minus 5b.
Would we want to take out that 5?
You can take out the 5, I guess. And then you'd have 5 times x, 5 times a negative b. Is that all right?
Okay.
Okay, so we're getting there, right?
Sure. Wait, we can take x minus b from both of those terms, and then you've got x plus b plus 5.
Because this is two separate terms, so
Right.
we can simplify that, and we can simplify this.
Yep.
So this cancels out that, we have x plus b
Plus 5.
Plus 5.
plus
5.
5.
Cool.
And now your denominator's gone. And I don't see getting that any cheaper.
Oh man, that's that's interesting.
That's algebra.
Yeah, it's very cool. I just hope I can find my way there in the future.
It allows you to take big, ugly, nasty things, simplify them like that, and then if you need to do something with them later on, like wrap them.
Mm-hmm. Mm-hmm.
Or whatever you might need to do with it someday.
Yep, there we go.
Yeah. All right, that's 11. No, don't erase that. I'll just pause your video. 13b. 13. We start with 13. Oh, no, they're two different ones. Find all the real solutions. 2 cosine squared theta.
Minus
Subtract.
cos theta
Plus 1.
I like them chunking.
So substitute cosine of theta.
x.
See, this, think of this as 2 times the cosine of theta times the cosine of theta.
What is that? What is it?
So you have to be able to look at it and see that. So now just call it x. 2x minus squared minus 3x plus 1. Is it factorable?
Yeah,
We need a positive and a negative.
positive.
And we need more negatives when we're done, so I bet that one times the negative. But it's gotta be 1 and 1. Does that work? Doesn't work.
I did both negative.
Well, oh, that's right, they have to be both negative, because a negative times a negative. Okay, good. Negative 1, negative 2 makes negative 3. Okay, sweet. Done. Now come back. 2 times the cosine of theta, subtract 1, times the cosine of theta, subtract 1. Now solve each of those the way we did way back in the day. So we have 2 cosine of theta is equal to positive 1, because we set that equal to 0.
Mm.
Are we supposed to factor solutions?
It just says.
It says
find
solutions. It says find all the solutions.
Uh huh.
So that means we want to find out when that's equal to 0. So this term is equal to 0. And then I added 1 to both sides. So now we divide by 2. And the cosine of theta is equal to 1/2. How do we solve that?
So you're gonna take the inverse cosine, it's gonna be pi over 6, or pi over 3. I wrote that wrong,
Pi over 3?
right?
I don't know.
Yeah, it's pi over 3, 60 degrees, right? Half.
No. It's cosine is equal to 1/2.
Yeah,
So that's 60 degrees. Third of pi. Yep.
pi over 6, right? Pi over
Okay.
6.
So there's one solution.
Oh,
So
active.
then the cosine of theta is equal to a positive 1, and that's out here, isn't it? So that would be that theta is
It's
equal
0.
to 0. So 2 solutions, second degree. Okay, now 14?
Yeah,
Find the sum of the fourth roots of unity.
I found them, but I don't know how to find
What are we talking about, unity?
4 I and negative I, or 4 negative 4 I and negative I,
And what?
and I and negative I.
Those are the,
Fourth
Wait, where'd you get that? Isn't it, it's when x to the fourth is equal to 1, right?
is that what it is? What's a root of unity?
Fourth roots of unity.
The x to the nth equals 1 are called the nth roots of unity. So the fourth root of unity is this. So we have to find the roots. We have to find the solutions. We have to do what? How do you want to do it?
Subtract 1 for sure.
You want to do it like this?
Sure. And then you got yourself x squared time to the second power minus 1 to the second power, or squared. And then you have x squared minus 1 and then x squared plus 1.
So this is x squared minus 1. So this is the difference of squares.
Yeah.
So we think of this as a squared minus 1 is the same as a minus 1, a plus 1 as factors. All right. Then how do we get out of this? Don't we have to take this out and turn that into 0?
Yeah.
So this is equal to 0. So then this is equal to 1. And then we can take the square root of that. And then 1 is equal to,
X is equal to the square root.
I'm sorry, x is equal to positive and negative 1. Do it again. Now x squared is equal to negative 1. We take the square root of that. And we come up and we say that's equal to the positive and negative square root of negative 1. That's I. Plus and minus I. So it becomes 1, negative 1, I, and negative I. Those are the four roots. 2 real, 2 imaginary. Fourth power, fourth degree. Get really smooth at it, and then you stop doing it for a year and you forget it all. Determine the 3 cubed roots of 125. We know there's 1, right? What's 1 cubed root of 125?
5.
5. 5 times 5 times 5 is 125. So I guess what we could do is we could say that n cubed is equal to 125. We know that n is equal to 5. So
You can have x, or n, or whatever, n cubed minus 125 and then do a difference of cubes.
so yeah, so you can rewrite this like this,
Yeah.
and then you can find the roots, and the roots are equal to the values of n,
Yeah.
which are the cubed roots. Okay, so that's like this
Difference of cube.
x cubed minus y cubed, right? So we can just do those two factors, so we have we would have n minus 5 as 1 root, and that's where your positive 5 comes from. And then you have n squared plus 5n,
Yeah. Plus 25.
Plus
and then you
25.
square it plus 25. And then the idea is that we're going to factor that. And we are not going to expect it to factor over the integers because this graph does this, doesn't it? It only crosses in one place. And it doesn't have multiplicity of 3. It has 2 places out here on the imaginary plane where there exist intercepts with that line again. So we're done with this. N minus 5 is equal to 0, n equals 5. One root. So this has to be done with the quadratic. And again, I think that it's really sweet to just do that discriminant right off the bat. Just concentrate on it, get it all done. Because you can get to the point that you can do that stuff in your head. So you have 25 minus 4 times 1
100.
times 25. So that would be times
So it's
it's
negative 75.
negative 75. So then we do this. And then change that right away. Bring I out. And then this is 3 times 25.
So 5i
Root
root
3.
3 over 2.
And then you put your negative b here over 2. So work that all out. A nice way to do that is this way. And that way. So 1, 2, 3. What is that, 14?
Mhm.
Good. We'll get it done before the end of the hour.
Are we gonna have a new lesson?
No, there's no more lessons in this chapter. You just have like 75 review problems to work on.
Okay.
18. Why do I have number 6 written there?
Because that's the one that was weird for us, or we thought was weird for us.
Wasn't it number 16?
But I think we're satisfied with that.
Mm-hmm.
Because we saw a similar answer show up. I think we're satisfied with not going and turning that into a mountain out of a molehill. 18. Determine the 3 cube. Oh, that was 18. I was thinking that we had done. Was 16 up there?
Oh.
What about Haley? 14. And we did that. We did the unity.
Mm-hmm.
The unity one. The last words in the reading. See them? Right there. Yeah. Maybe see you tomorrow. Maybe see you in a month. You know more than they do, don't you? Dun, dun, dun. See you later.
Yes. It's just like a